Okay, welcome back to our ELM prep series, part 17. We're going to look at graphing quadratic equations. A lot of the questions dealing with quadratic equations, at least in the graphing, is they give you some equations such as y equals 3x squared plus 5. Very simple. Well, we'll make that even more simple. We'll just say x squared plus 5. And then I'll say, well, what graph looks like that? So I'll give you a bunch of graphs, usually 5 graphs. I only have room for 3. So first of all, the quadratic is going to be U-shaped. It will either be an upward U or a downward U. This is a positive, this is a negative. If the leading term here, the x squared, is a plus value, then it will be shaped up. If it's a minus value, then it will be a downward shape. All right, so given that, we're going to plot this. Now, one of the ways to look at this is I let x equal 0 and find out what y is. I'm going to just draw a few graphs here. And like I say, there are usually 5 graphs in your answers. But whether you have 3 or 5, if you recognize how to find what you want, it doesn't matter how many. Well, obviously we said this is plus, so our U shape is going to be up. So we're going to look at this and say, nah, it's a downward shape. So definitely that's not one of my answers. So maybe the rest of them are negative. I'm left with 2 answers. Well, they're both upward shape. So what do I do now? Well, just like in the linear, we're going to look back here and see, well, if x equals 0, y will equal 5. So 0, 5 is that point, 0, 5 is that point. This is the only graph that has that point on it. So this is not my answer. All right, so that was easy enough. Okay, well, let's just change one thing. Let's make this a minus this time. Well, graph, graph, graph. And I'm going to do this, and do this. The heck, we'll do something like that. Okay. So I asked myself, what is the general shape? Well, it's a downward shape. It's a negative, so it's down as a frown, negative as a frown, and so my curve goes down. So right off the bat, that's an up curve. I'm going to throw that answer out. Well, I have 2 down curves, so now I have to look a little closer. I look back here at this plus 5. Well, if x equals 0, y equals 5. X equals 0, y equals 5. That's not on the curve. X equals 0, y equals 5. That is on the curve. So this is going to be my answer. I'm going to throw this answer out. Well, that wasn't too hard. Seems straightforward. What I want you to do is not necessarily determine any of the 0 points on this curve. I want you to recognize the general shape of the curve first off, and then if I have 2 that are the same shape, then I will look to see where the intercept is. All right, let's say I have a little more complicated equation. Y equals 2x squared minus 3x plus 4. Okay, so they give me some graphs again. And they give me a graph like this, and they give me a graph like this, and maybe they give me a graph like this. All right, well, First thing I do is look at the leading term of the x squared, and it is positive, so it's U-shaped up. Well, this one's out. U-shaped up, U-shaped up. Okay, I now have 2. So if I let x equal 0, all that goes to 0, and left with 0, 4. 0, 4 is possibly there, possibly there. This is obviously a negative, so this one is out, and I would take this as my choice. Again, look at the general shape first, and then look for the particulars. Where am I crossing my asymptote? If x equals 0, then all of this will go away, and y will equal whatever's left. Okay. Hopefully they're simple enough that you can do that with them. All right, so we're going to look at y equals minus x squared plus, I'm going to do a different form here. They might give you this, x minus 3 quantity squared plus 2. Okay. Let's see if our other method will work. We may have to resort to something else. Okay, I'm going to look at okay. This graph should have. Okay, we'll go with that. Well, if I were to FOIL this x minus 3 out, I could FOIL it out, and I would have some value. But first of all, let's recognize that even if I FOIL it out, I have a positive here. So I have an upward graph. So my overall shape is upward. So I'm going to throw this one out. Well, if I let x equal 0 here, this will be minus 3 left over. Squared will be 9, plus 2 would be 11. So I should cross at a plus 11. Now both of these cross at possibly the same point. So now I'm left with an additional problem, and I'm going to look at this term right here. This being in the parentheses says that I shifted my graph, my vertex point shifted to the right by this amount. I take the opposite sign, so it shifted to the right by 3. Well, this vertex seems to be right on the y-axis, or x equal to 0. This one over here, my vertex seems to be shifted over here to about 3. So in this case, I would choose this as my answer. Excuse me. This is a little trickier problem, but if you look at the shift, lots of times just knowing the shift and that it's positive will get you the right answer. If not, you can look at a little closer detail. And if I had 2 of them that were very similar to this, maybe one of my other graphs came down like this, and I then might have to look to see which vertex was actually shifted over 3, or I might even have something that was shifted like that. They both cross at the same point. This is shifted to the left. That would be caused by a plus 3 inside. So whatever is inside the parentheses with the x, that will cause it to shift left or right opposite to the value. All right. That was a tricky little piece of stuff right at the end of this video. And what we discussed was quadratic equations, plotting those, and looking at the graph that would be a possible solution to those. All right. Have a good day.